All right, guys, here we are, number 3 of our Module 2 Excel report. Let's see what we're going to do with number 3. For number 3, we're going to look at some statistics on impaired driving. We're going to use bar charts, histograms, and Venn diagrams. Again, don't get afraid. We're not going to have to type all that notation in our Venn diagrams. We're going to do these a little different. It's actually a different kind of Venn diagram. It's called a proportional Venn diagram. I think you guys will like it. We're going to explore the transportation report for fatalities in vehicles. We're going to look at the difference in fatalities between genders, road users, location, age group, and level of urbanization. And then we're going to come down and look at some data reported in the Dave Sebecki, Brian Mercer Quantitative Literacy textbook about reaction times of adults with a blood alcohol level of 0.08. We're going to take this data and we're going to actually create a histogram just for you, Tinny. We're going to create a histogram and do some cool stuff with the histogram, talk about the distribution of the data and different things. And then we are going to also calculate the median, mean, standard deviation, and coefficient of variation. You guys remember all that. The next thing we're going to do is follow another link. And this link is going to take us to some data on impaired driving that was put together in British Columbia. And we're going to discuss why or why not some samples of data can or cannot, or should not, be projected onto another population. So we're going to look at Venn diagrams, percentages, probabilities, and talk about samples and populations. So this is a pretty good contextual scenario we have going on here. We're going to do all different sorts of graphs, but you're going to see that they're actually all pretty simple. We're going to look at the Transportation Accident Commission report, and we're going to talk about the differences between 2018 2019 and ask the question, are we learning anything? We are going to use the World Wide Web to find out how much alcohol a person does need to drink to reach a blood point level of 0.08, which may used to have been legal limit. I think it's lowered now. You guys can Google that, I'm not sure. We're going to talk about the distribution of data of reaction times we find in our histogram and the meaning of the Venn sections of the British Columbia data. And then we're going to talk about how we would relate that to our population. And then just for fun, for number 5, something I'm curious about, I personally feel like driverless cars would solve so many problems. We have so many deaths from vehicles. So if we can master that, we might be onto something. So I want to know your opinion on that. What's your opinion about driverless cars and all these problems? You might think they would cause more problems. I'm curious to see what you think. All right, so we're going to start off by following this very first link up here. So I have already, well, let's go to our Excel report first. I've already put some stuff in the Excel report, my name. This is actually number 3. And then impaired driving, and that's also what I labeled it down here at the bottom, impaired driving. So now I'm going to go to this link. You guys are going to like this. You know how I keep saying work smart, not hard? You're going to be like, why couldn't I just do this for everything? Well, because we have to learn how to put data in to the computer. All right, so this is not getting smaller for me, so I'm going to press minus. I know you guys don't like it small, but I do need to have it small to select this. I am literally just going to select all this data. I'm going to start right at, wow, look, daily lives lost. Can you believe this? Let's just take a quick look before we move on here. Daily lives lost. The average number of daily lives lost in 2018 was 31. That means over a whole entire time period, an average of 31 lives a day were lost in vehicles. Well, in 2019, it says we're up 48%, a 48% increase in deaths per day. And it says we're averaging 46 deaths per day in vehicles. But think about this. Is the death rate the same in January as it is in June? I mean, I'm thinking that maybe in January we might have a worse time because, first of all, New Year's Eve is counted in that time. So anything after midnight, and statistics show all kinds of terrible things that happen with vehicles on New Year's Eve. and other information. Roads are icy everywhere. It's winter time, so it's possible, and I'm conjecturing. I don't know all this stuff. I'm just guessing, making hypotheses that there would probably be less car accidents in the summertime because there's no ice on the road. Maybe seasons where it's raining or not raining. So we can't really look at 2019 and say we're not learning anything because we don't know yet. So the answer to have we learned anything, we don't really know because we can't use this average over, this is only February, so we can't use 2 months worth of data and compare it to a whole year's worth of data. So that's the answer I'm looking for when I ask you to compare those two. Now, I'm going to choose this daily lives lost. I'm going to start there, hold my mouse down, and I'm just going to select all the way down to right here. And we're going to talk about the rest of this data, but I want to talk about it in Excel. So now coming back over to my Excel, I'm just going to click somewhere. Be careful if you're double clicked, if you have the cursor prompt in your cell, you cannot just paste stuff. You have to have a generic, just one tap, and then you can control Victor. So you guys can see that I have this great big thing happening here. I am going to grab this Delta 7 here, and you guys don't have to have yours in Delta 7. You could have put it anywhere. I've been getting a lot of questions about, just that address. It doesn't have to be different. So I'm going to drag this over how many spaces? I'll tell you how many spaces. I'm going to line it up with this chart down at the bottom. So I'm just going to grab this cell with my wide white cross cursor, one click, hold, drag, and let go, and then I am going to merge. So right up here, I have this icon that says merge. I'm going to merge those. And then I'm going to make it narrow. And then again, I am going to do the same thing here. And I'm just trying to make stuff look neat, because what is the purpose of building mathematical models? To torture you? No. We build mathematical models to give others an at-a-glance view of the data. Because honestly, folks, how many of you are really going to look at all these numbers if you had a graph? If you have a graph to look at, that's what you're likely going to see. All right, so now here I have, and you guys can, do something with these two little pieces, whatever you decide to do. But I'm going to just start here. Grabbing this data, I'm going to move it over. See how I selected it? Just do that one more time. I have you guys want this bigger, I know. I have my thick white cursor in the top cell. I only had one click. If I double click and I have that, it will not work. So one click, hold it down and select all of that, and then I can just move it right over here. You guys are going to put some borders on it and, color pieces, make it look good. Color the different sets of information that you have going here. And then you select all of this data, this little chart, and insert a bar chart. And you guys can do a vertical bar chart, or you might choose a horizontal bar chart, however you decide. I'm just going to put a vertical in here for now. And then what you guys are going to do is move all of these little charts around on your Excel to some places and just make it look nice. So I've already done this, and what your guys's are going to look like is something like this. Except your graphs are going to be, your charts are going to have borders around them, and they are going to have colors. It's not going to take you long to make this look nice. This whole first part of this scenario has 3 pieces, and this first part should take you really just 10 to 15 minutes. Cut and paste, select the chart, insert the graph, and then move stuff around so you'll have a page that looks about like this. Now, you guys are going to talk about some of this data. For example, this is interesting. I found this very interesting on my age group. Well, what is the greatest probability of dying on the road? Well, it's not children. Children have a very small chance, a very small probability of dying on the road relative to folks 70 and over. Look at folks 70 and over. They have a much higher probability of dying on the road. So, and some people, we don't even know their age when they're found. And you can see really, wow, the 70 or over has a huge difference. So you guys are going to talk about not every single thing on all of these charts, but you're going to mention a few things that you find profound. On the 70 or older, the things that I thought about were the medications that older folks take. If you looked at all those charts on the genetically modified foods, genetically modified organisms inside of our foods, you will see the increase also correlation with Alzheimer's and other deterioration of the brain diseases. So that could also have a lot to do with our over 70, because as we know, as we age, those, the GMOs and all of the things around us affect us more greatly. So there could be all kinds of reasons. Now let's move on to the second part of the scenario. So that's everything we're going to do for the first part. The second part, we have this chart. Reaction time in seconds in adult subjects with a blood alcohol level of 0.08. I am going to just select this whole chart. You guys should be able to select this chart like this too. Mine's in a Word document. Your guys' is going to be in a PDF. So once I select that data, I am going to come over here to my Excel. You guys are going to have, this is my old page. So you guys are going to set up this page. It's going to look nice. You're going to move all this stuff around like I just showed you. And then below it, you are going to put in this data. I'm just going to paste this chart in here. All right. So when I did this, I practiced doing all this before I made the video, and I typed all of these in. So if you have to type them in, I've already just did that. But then I actually thought of an easier way right in the middle of making this video just a few seconds ago. I am going to select this. It was when I was moving those graphs around showing you guys, I thought, wait, I could do that for this part. So I'm just going to select this data, and I'm just going to move them all over and put them in a row here. I mean a column. I meant to say a column. Cool, huh? So yeah, just a second ago, I sat with my finger on one part of the screen going down in a row while I typed with my other hand. And now I don't have to do that, because Excel allows me all kinds of cool ways to take shortcuts. Lots and lots of ways I don't know about. All right, so now I'm also going to take this list and move it down. Just a little. Because I am going to be, I know you guys, I have to have it this size so I can see everything. So I am going to be calculating my median, my mean, my standard deviation, and what else? My coefficient of variation. Now, do we remember how to do this? It's okay if you don't, I'm going to show you. But really, you totally should, because why? We just did this in our health statistic, right? And we did it for Module 1. So I hope you can see that finding this data is important, since we are doing a lot of it. I'm going to do my median, press equal, type in MED, double click, and then I'm just going to select this list of data. And folks, you see mine says delta 80 through delta 104. Yours doesn't have to say that. Yours can say, you could have pasted yours anywhere on your document. So yours will not be the same as mine. Okay? I found that happening quite a lot. People were very mindfully going to that same exact cell and pasting stuff in. You don't have to do that. All right, and then for my mean, the mean is the average. So I type equals average And I'm going to select my data here. Enter. Sorry, I need to make it just a little smaller. My standard deviation equals STDEV. That's it. Don't use any of the other ones. We have standard deviation for a population, for a sample, and some others that I do not know what they're for. But we're going to use just the one that's STDEV. And again, we have this set of data. Now, the coefficient of variation is the ratio between the standard deviation divided by the mean, if you guys remember that. All right, so now I have found that much information. The next thing I'm going to do is insert a histogram. Now, if you don't have Windows 16, you're not going to have a histogram option. So you might need to either Google a free add-on or use somebody else's computer on the campus, library, a friend at work, something. But try to get that histogram in there. I am going to insert a histogram. Now, look, you guys, we've been dealing with bar charts. Bar charts have spaces in between. Bar charts represent individual data. Each one of these bars represents an individual piece of data. But we don't want a bar chart. We want to insert a histogram. That's this other one down here, and it is a statistical chart. A histogram. All right, just a second. Okay, because I used that bar chart first, for some reason it did that to me before too. Excel wouldn't give me a proper histogram, so I had to go undo a couple things and then come back, and it lets me now use the histogram. So don't click on bar chart. If you click on bar chart first, you're gonna have to go back and undo a bunch of stuff. All right, so now I have a histogram. You guys can see that my histogram covers a whole bin of data. We actually call these bins. This has 4 bins. And a bin has a range. This one goes from 1.2 to 1.9. If you guys can see that at the bottom of mine. If not, hopefully you can see it at the bottom of yours. I want my histogram to have 7 bins. That's what it says on my sheet here. It says to calculate the mean, median, standard deviation, and then it says create a histogram with 7 bins. So let's go back over here, and I am going to, of course, always add axes titles and label my chart. I'm going to click on my independent axis down there, and I am going to click over here on the right on number of bins, and I'm going to change it from 4 to 7. And there we are. And you guys can see that the distribution, you're asked in your 5-sentence report to discuss the distribution of this data, and you can see that the distribution creates a nice bell-shaped curve. It is normally distributed, which means that we didn't have anybody who had an outrageously low reaction time, and we didn't have anybody who had an outrageously high reaction time. The reaction times had a normal distribution. So you guys are going to look at these reaction times. You can make some comments about them. The mean reaction time for somebody with a 0.08 blood alcohol level was 2.4 seconds. So, you know, if you really think about 2.4 seconds, how long would it take me to pick up this pin right here? You know, if I don't know what their tasks were, it doesn't report what the tasks were, but just the reaction time in general, that kind of seems like a long time to react to something, 2.4 seconds. All right, so let's just make sure, see if we're missing anything here. Nope, that was everything that we were supposed to talk about. Now we're ready to move on to the next piece. We have one more link to follow, and we're going to create our proportional Venn diagram. So let's have a look at that link. All right, so just one moment, please. Okay, so we're going to look at this link, and this is the one where I keep telling you guys about the British Columbia data. So we're going to actually look at a report put out in British Columbia, and they did such a beautiful job. I couldn't find anything like this for our country. which is fine because it turns out that we get an opportunity to talk about populations and samples here. Look at that beauty. So to create this graph in Excel, we would use some trig. We would use our sine functions. And this graph actually, do you guys remember how we calculated the area of the two circles for the misleading graph in number 2 for Excel report number 1, our first Excel report? And we calculated the area of those circles and found, that it was 13%. Well, we could actually do that for this too. We could find the area of this whole green oval here, and we would find, well, we're supposed to find that the percentages would pan out. So it's supposed to be created actually visually proportional, as well as those numbers put in there. So it's supposed to be that this piece where it says 3.7% is actually 3.7% of the entire oval. I don't know, like just looking at it doesn't really seem like that would be 3%, but that's what a proportional Venn diagram it does, is the actual areas covered by that is supposed to be the same amount of area. And I could be wrong, maybe it's not just 3.7% of that circle, but maybe 3.7% of the entire area. So we're not going to look at that. That's a little beyond the scope of this course, but we do want to know what a proportional Venn diagram represents and how it reports. So we are going to recreate this. We're not going to use our trig functions. In Excel, we can actually tell Excel how much data we have and give it the percentages, and it will actually create this for us. I don't know how to do that yet. I'm going to learn this summer, and next semester when we do this problem, this scenario, we're going to actually build this. But for now, we're going to build it a different way. We'll just use the tools that we do know how to use. And I am going to snip this just to have a reference in my Excel report. I actually just thought of another thing I didn't think about when I practiced this earlier. Just thought of it right this second. I'm going to paste this in here, make it smaller. And we are going to recreate this by inserting ovals. So I'm going to, let me just go just a tiny bit smaller here. We're going to insert shapes and text boxes to create this. And we did that before. We've done this with our Venn diagram, and then we created these transparent shapes, remember, on our bell-shaped curve. So I'm going to insert an illustration, a shape, and a circle. Or should I say an oval? All circles are ovals, but not all ovals are circles, right? Like all squares are rectangles, but not all rectangles are squares. All right, so here I have my first oval. I'm going to right-click, format my shape. I am going to make my line white. This is the line. And you guys, if yours is on a different thing, you just click on the paint can. I'm clicked on line, and I'm going to make it white. Just because that's what they did. And then for my fill, I want it to be transparent. And you guys are going to be cautious not to make yours the exact same color as theirs. Don't make it look exactly the same. If yours is exactly the same and I click on it and it is not created, it was copied and pasted, then you won't get any credit for it at all. So here I have this, and I can actually, I'm just going to leave this one blue, and I'm going to Control Charlie. How many circles or ovals do I need? 1, 2, 3, 4 ovals in this teardrop shape. So I have a Control Charlie, Control Victor, Victor, Victor. I just created 3 more ovals. I'm going to change this. Whoops. I can actually change this color, go to Shape Fill, and I can make it all these different colors that I would want to. Shape Fill, maybe make this one yellow. And then maybe this one can be, and you guys could go to more colors. And you can actually choose all kinds of different stuff that you would like. Now you have all these colors, and what you guys can do, this is the thing I just thought about, because when I practiced this earlier, I was actually just like making these shapes and trying my best to recreate it. You would grab this little thing and you could turn it around, all right? But what I just thought about a second ago is, heck, look what I can do. I can actually just put it right over the top of this and get it to be the right size. So you guys can actually recreate this pretty darn close just by using these little tools. All right, so here you have one piece, and then the next piece, just put it on there and try to make it about the same size. And then it goes here, and then you guys are just going to keep creating these to look as much as you can like the proportional Venn diagram that we have over here. All right. I don't know. This doesn't really look that close. Looks like these need to be in more. But you guys are going to do this. And then the last piece that I have is this little teardrop shape. So I can go up here to Insert, Shape, Illustration, Shape, and grab, it's actually called a teardrop. Right down here under Basic Shapes. You put that teardrop in there. And then you are going to turn it whichever angle you need it to go. And then you can kind of just drag it around to skew it how you need it to be. And then of course you are going to format this shape and make it transparent also. All right, then the next thing you guys are going to do is insert a text box. And in your text box, you're going to write the stuff that you need to have in here. And, you know, make everything look real nice. Whoops. So once you guys get your little text box here and you put it where you need it, you can select that text box, format the shape, and where it says fill, you can just say no fill. And now you have a nice text box without the fill behind it. Another thing that you guys can do is insert an illustration. We could have really started with this. I actually started with this when I practiced it. Insert a big old rectangle, and then I want my rectangle, I'll just make this one white, and then I right click and send it to the back. And now I can actually build my whole chart on top of this. All right, so you guys are going to build this chart, but then you're also responsible in your 5-sentence summary to talk about this chart. So let's see what it means. When we're talking about the chart, I'm just going to go back to the website to look at it. We see, first of all, we had 59.9% of the population had no, well, I guess I didn't even really talk about what all this is. This is a Venn diagram showing us the different substances that people had in their bodies when they were in a car accident or a vehicle accident that they were injured. So we can see here that 59.9% of the people injured in vehicle accidents for this study had no substance in them. But we see that 11.7% of those were on some type of medication. It doesn't specify if it was over the counter or prescription. And really, if you look at all of these percentages, the biggest one was medication. So 11.7% of injured drivers in this study were on just only a medication. 3.5% of drivers that were injured were on a medication and some other recreational drug. We can see that 0.4% of injured drivers, that didn't really work out. 0.4% of injured drivers, now I can't see everything, were smoking marijuana with some recreational drug and on a medication, or no medication, sorry. This one right here, see this VIN section? This is only marijuana or cannabis and other recreational drugs. What about this one right smack in the middle? Yikes. These guys are 0.2% of all the people that were in car accidents with injuries in British Columbia for this study. 0.2% of them had alcohol, marijuana, some recreational drug, and a medication. So you guys see what these VIN sections mean? And then, so you would talk about, 59.9% of the population who were injured in accidents in British Columbia had no altering substance in them. And then, talk about the rest. It looks like it was more likely that people had just alcohol than alcohol with any of the other combinations. So talk about those probabilities and what the percentages mean. Talk about the Venn diagram and how the sections intersect and how that means that both things happen at once, and how the numbers that are reported alone in a section mean just alcohol without all the others, any of the other substances. All right, guys, I do believe we have wrapped up our scenario here. And let's see, yep, we've done everything. We talked about the transportation report. We created all those bar graphs. We did our histogram with the reaction times. And then we talked about the VIN sections from British Columbia. And also when you guys talk about that, we're going to think about the population of British Columbia. Could we project this data onto our population in our country? Well, I had a lot of different thoughts about this. At first I thought, well, yeah, we're like the same, we have the same styles and a lot of the same personality traits, the same sense of humor. So why couldn't we use this data from British Columbia and say that it would predict the information for our country? But then I started thinking about other stuff, like in British Columbia, that's a much smaller space. I think there are many more people per square mile, and they are more likely to have public transportation. So for us, here in America, we don't have as much public transportation. We have a lot more open space, a lot more rural areas. And look at this. This was interesting. If you go back here to your graphs that we did, where was the road users? Look at this one for road users. Do I have a little graph for that? Sorry. I guess, oh, there it is. So for road users, not road users, sorry. Okay, look at this one with the location. The location where it says Melbourne, that means a city area, like an urban area, the Melbourne and the rural. Here we have the number of accidents in city areas and the number of accidents in rural areas. Do you see how much greater the rural areas are? We also had another piece of data on here where it showed us actually urbanization. Where was that graph? Sorry, I know I'm making you guys dizzy, but I want to show you this. I thought it was, here it is, urbanization. So for this chart for urbanization, it shows us the number of accidents on small, sorry, I'm just gonna make this a little bit wider here, just so we can see it. So for cities, we have like towns and stuff, that's the blue. And then we have our rural roads is the orange. You see how many more accidents are happening on rural roads? Why? I don't know. It could be maybe impaired people are driving back there trying to stay off the main roads, or maybe in the areas that are more congested, we have more public transportation, so there are less personal vehicle accidents. There are all kinds of reasons. But because of this data with the rural, much higher fatalities on rural roads, that's why I thought that we really couldn't project this data, because we probably have way more rural roads in America than they do in British Columbia. So those are just some reasons why we can't always take data from one population and project it on to another. We want to make sure our samples are similar, have similar characteristics. All right, guys, that is the end of scenario number 3. We're going to now look at scenario number 4. So I'll see you in just a minute.